Hey everybody, welcome back to Beyond Basics with Madiha. In the previous sessions, we've explored the fundamentals of data structures and algorithms, what are arrays, how to declare them, how to use them effectively. But today, we're leveling up. In today's video, we will take a real world problem based on arrays, understand and break it down step by step as to how we approach this problem and how to solve this problem, how to think logically, and finally, how do we land coding this problem. So if you're new here, make sure to subscribe the channel and stay tuned till the end. So without any further ado, let's dive into the very first problem. Find the largest and the smallest element in an array. Step 1 is going to be understanding the problem. So any problem that you come across or you pick, the very first step that you're going to take forward is going to be understanding the problem and having clarity with the problem statement. So let's read again the problem statement here. Given an array of numbers, return the largest and the smallest number. Always have clarity with the problem statement and understand it better with the instances or the examples that they provide to you. Here we have an example input and we have couple of numbers in this array. 3, 5, 7, 2, 8, 4. Now what is the requirement? We have array of integers and what do we have to return? The largest and the smallest number from this array. So according to the example, the largest element that you see in this array is going to be 8 because there's no number greater than 8 if you see in this array. And the smallest element is 2. And there's no number lesser than 2 if you see in this array. So right now we've understood the example statement, the problem statement better with an instance as well. I repeat, the problem statement is array of numbers. We have to return the largest number from this array of numbers and the smallest number from this array of numbers. Like we have seen in this example statement, 3, 5, 7, 2, 8, 4. The largest is 8 because we don't see any number which is greater than 8 or any number that's smaller than 2. All right. So this is the problem statement and we've understood this very clearly. And one tip that I give you here is without understanding the problem statement, do not dive directly and start coding the problem. Even if you do so, you will not end up solving all test cases that they provide to you. Okay, you cannot, dry run and pass all the test cases because you have to have all clarity with respect to the problem statement. Only then you can code it better and you can clear all the test cases and the test would provide it to you. So let's move on to step 2. Now the step 2 is breaking down the problem. So we have understood the problem statement, but how do we solve this problem? So you start thinking, brainstorming. So one idea that you come across is that will strike your mind here is, since we have to capture the biggest element and the smallest element, so this something involves comparison of the elements because you have array of integers, multiple numbers. And among those numbers, you have to come across or find the biggest element. So if you want to see the biggest element, then you'll obviously compare those elements. So if you have 3, you consider 3 to be the biggest. But when you reach forward, you will see 5 and you again compare 3 and 5. So 5 apparently is bigger than 3. So now you say 5 is the bigger element. Likewise, when you keep moving ahead, you will come across 7. So 7, if you compare with 5, again, that is going to be bigger than 5. So likewise, since this is bigger and smaller number, this involves comparison of elements. So this is something that you'll reach at a point. So this will strike to everybody's mind that since there is biggest element, smallest element, so we have to compare the elements. Now, we have broken down the problem. So what is step 3? You have to think approaches. We have understood that this involves certain comparison, but how do we compare this now? One thing we can do here is sort the array and pick the last element. So when you sort the array, what happens? Obviously, the biggest element will appear at the end of the array and the smallest element will appear at the first position of the array. So we can pick the first element will be smaller element and the largest element being the greatest element. Option 2 again is traverse the array once and keep updating the max and min value. So the second option is we will traverse the array and we will keep updating. So we'll keep comparing the elements. And once we find some element greater than the current element, we pick that as the bigger element. Likewise, we keep moving on. But now when you have two approaches, how do you decide which approach to choose? That is based on the time complexity. If you see the sorting, this is going to take big O of n log n. And the second option is going to take big O of n. So now if you compare the time complexities here, option B is clearly better because sorting requires more amount of time, but we'll always have to choose based on less time taken. Okay, the performance has to scale up, and the performance can scale up only if the time consumed is lesser. That is why we cling to option 2. Step 1, we understand the problem statement clearly. Step 2, we break down. We start collecting hints as to how do we solve this problem. Third, when we come across multiple approaches, we decide which approach to cling towards. All right, so this is step 3. Now, once we've come across all the steps, the next thing that we're going to do is we will dry run this. That is step 4. So we have array 3, 5, 7, 2, 8, 4. Now the solution that we've come up with is we will keep updating the maximum and minimum value as we traverse through the array. So initially the maximum value is going to be the first element of the array, that is 3, and minimum value will also be the same element 3. So the starting element will be the maximum element as well and minimum element as well. And we keep moving forward. So we start from 5 and then we check. If 5 greater than maximum, because since we have to find the largest element, so the condition that fits right is greater. So we will see if 5 is greater than the current maximum value, that is 3. Yes, it is. So what do? We update the current maximum element. So now 3 is no longer going to be the maximum element. Instead, 5 is going to be the maximum element. Now we again check for minimum value as well. So 5 less than the minimum value? No, 5 is not less than 3. In fact, 3 is less than 5. So the minimum value will still be 3. So in our case, maximum value is changed to 5 and minimum value will still remain the same, that is 3. Now we move on to 7. Now 7 will be compared to the current maximum value. And what is the current maximum value? That is 5. So is 7 greater than 5? Yes, it is. So now the maximum value gets updated to 7. Now we see, is 7 less than 3? No, it is not. So still the minimum value is going to be 3 only. Likewise, we keep moving on. So now 2. So 2 is greater than 7? No, it is not. So the maximum value will be 7 only. 2 less than 3? Yes, it is. So now the minimum value will be updated to 2. Next element 8. So 8 is greater than 7? Yes, it is. So we update the maximum element to 8. 8 is less than 2? No, it is not. So minimum value will still be 2. Next, the last element is 4. So 4 greater than 8? No, it is not. So it will be the same. Maximum element is still 8. 4 is less than 2? No, it is not. 2 is still going to be the minimum value. And we've reached to the end of the array, which means we've deduced the largest and the smallest element, which is 8 and 2. So when we dry run the solution also, we've got more clarity, and now we can straight away jump to coding this solution, which we will see in the coming slide. Now step 5, coding the solution. So we have this find min max method in which we are passing the array of integers. For now, let's ignore this value and we will look at this section of code, and then we'll get back to the value, the statement that we've ignored. So current minimum value, like discussed, will be the first element, array of 0. Current maximum value, again, array of 0. Now we are traversing the array. So for every num from this array, what are we checking? If num is less than the current minimum value, we update the current minimum value to num. If num is greater than current maximum value, we update the current maximum value to num. If not, the current minimum and maximum value will remain as is. Now, once we traverse the entire array, what happens is we come across the maximum and minimum value being stored in these variables. So we have to return the array of integer which has max and min value. So we create a new integer, shove in the min value, shove in the max value, and return. So that way we've solved the problem. Now step 5 or 6 in coding, one thing you'll also have to be considerate about is the edge cases. So this is something that you have to pay attention towards as well. The negative scenarios. We have understood the solution, we have dry run the solution, we have solved the problem. The next thing that we're going to do is edge cases, negative scenarios. What if the array that is given itself is null? Or what if there are no values in the array, the length of the array is 0? What to do in certain cases? That also you'll have to decide, or you can ask the interviewer itself. So in certain edge cases, what do you want me return? Accordingly, you can return those values. But here we've considered in such cases where the array is null or the length of the array is 0, we will just return the minimum value and the maximum value according to the nomenclature that's set in Java. Okay, so this is how we solve the problem, we code the problem, and we are also considerate about the edge cases. Moving on, we will understand further about part 6, which involves complexity and edge cases. Like discussed in the previous slide, the time complexity here is we are only traversing one loop. So therefore, it is going to be big O of n. And space complexity is big O of 1 because we only initialize or make use of two variables, current min and current max. Nothing else is being created. So that can deduce to space complexity being big O of n. So we have done it very optimistically, right? Now, the edge cases that I did speak about in the previous slide is empty array. So we have to decide upon when you come across such cases, how do you manage the response? If there's only one element in the array, then the minimum and maximum value both will remain same. So in such cases, how do you manage the output? Whereas if all the elements are equal, then both minimum and maximum value again will be equal, right? And if you have a large range of arrays, then you have to be sure about how you traverse the array and all of that. So things that you have to remember is understanding the problem clearly and illustrating it well with the examples. Second thing, breaking down. So collecting on how do I solve this problem. And once you come across the brute force approaches or various kinds of solutions, which solution do you pick? That will rely on the time complexity that is proportional to the time complexity. Then we start dry running the approach. Then we start coding the problem. And once we've cleared certain test cases, the test cases that you'll get stuck at will be these edge cases only. So then you have to run your brain thinking more beyond. What if the array is empty? What if the array has no values? What if the array elements are all same? Then in such cases, how do you tackle the problem will help you clear the remaining test cases that you're stuck upon. So these are the steps that you have to pay attention towards in order to solve any problem. So these steps remain the same whether the problem is easy, moderate, or very difficult. The approach remains the same. This brings us to the end of the video. If you found something knowledgeable, then do like, share, and subscribe to stay tuned. And we shall see you on the next video of DSA.